Alright, welcome back. So we just formatted our tapes, so we've got two tapes. Which one is on right now?
The 896 block.
The 896 block tape. So we have that. We also have a link tape that we can try to test out. And again, we're running the tape data test, and this is the test that is the third test. So that second test that we did passed after we cleaned the card and potentially reseeded it. We don't really know what the problem was. Now we're on to the third test, and this is the test that's failing. Dawson, if you can show the manual here. I can't remember if we've showed this in a video before yet, but what this is going to do is test read and write, do some stuff for the data on the disk, or on the tape rather, and it says we should already have done tests 1 and 2, which we've already done. We've already got the tape loaded and everything should be ready to go. We're supposed to start this in 8 mode at address 4000.
Okay.
Oh, that's for the bin loader. That's for the bin loader. I was like, 8 mode, really? I thought this was link mode. Starting procedure, my bad. So we will set the left, right, and center switches all to 0, which is a standard operation. The mode switch should be set to L mode, so this is a link program. IO preset and start 20. So before you hit start 20, let's see what the tapes are going to do. Wow. Okay, well that's new.
I didn't have the tape far enough on it.
Perhaps the tape, I'm hoping that it's more than just the tape wasn't far enough on, but...
That's what it was.
Okay. So we're gonna rewind the tape. Alright, we'll try this again.
So, we can start it out in the middle of the tape.
Let's try that.
And then if it does the same thing, it probably doesn't like the format of this tape.
Sure. Could be looking for a block that it's not finding.
Exactly. However, they mark the block numbers on the tape, and it's not in the right format.
Yeah.
Oh, the program's still running anyway.
Oh.
Sticky switch. I think that's I don't like this tape.
But it didn't even try to load the tape this time.
Yeah. Okay. I'm trying to reload the program.
So this is new behavior for us. We haven't seen this happen before. So you're going to re-execute, or do you want to reload it, or what are you thinking?
I'm thinking reloading the program from the bin loader.
Okay. Okay. So Dawson's going to reload the bin loader. Just up a level, I think.
Or bin loader should
bin loader's loaded, right.
That's probably a no.
Alright, we're back, and we've got the tape data exerciser loaded in, and we have our 896 block tape loaded, and we're going to see, last time we did this it kind of acted weird. We reloaded the program after a bit of monkeying around. Now we'll see if it works. All right. Well, that's the error that it was giving us before. So when there's a problem, what it's supposed to do is run and then quit at the beginning of the error, and then if you hit continue, it just reruns the test, and you see it's rerunning and it's failing in the same way every time. So what Dawson and I thought might be interesting would be to show how we can single step through a program, because we're basically, if we look at the instructions for this program again, this is the one that says like, oh, what are the error messages? Oh, there's actually no error messages. The only way you can figure out error halts is by looking at the program listing. So what that means is we need to look at the program listing to figure out what's going on. Program listing is down here. And Dawson, if you could hit Control right arrow, it's going to rotate that screen. Maybe click on the document. Oh, there we go. Okay, thank you.
Control, not.
Yes, okay. So what we're going to do is show you how we can single step through the program. How do we start doing that?
Well, I would always restart, clear out all the registers, preset everything again. And then you hit your single step key.
Yep.
And since this is a start 20 program, we hit start 20.
Yep.
And it is waiting at the first address. So we're at address 20 in our instruction field that we're in.
Yep.
And so we can hit continue. And now we go to address 22, and the program counter is pointing to 23 to 24.
Okay.
So from there we can look at the data that's in the address, what should be there, where the program counter is pointing us to next, what processor states we might be in, and try to decipher how the computer is doing what it's being told to do.
Yeah. So let's restart at 20. So you may have noticed that it went from 20 to 22. So if we look at start 20, we look at the first instruction here. So 20, it says SNS I5. So start is the beginning of the program. SNS I5 is looking at the sense switches, and it's checking to see if sense switch 5 is set. Okay, and if it is set, then we're going to do the next instruction. We're going to jump to this L scope target in the program. If it's not set, then we're going to go to 2022, and instruction is going to be 011. So we're still at instruction 20. So go ahead and single step that.
Yeah. And one interesting thing I just remembered is that we have our skip flag that gets set. So we can tell if it's a skip instruction that's being executed or if we're skipping an address. So if we start 20, sense switch 5 is not set, so we're skipping. But if we have that set, we're not skipping.
Oh, that's cool. So the console tells you, hey, heads up, we're about to skip the next instruction, basically, because of the setting of this switch.
Yep.
Okay, so if we hit continue, now we've jumped to 22, okay, and where's the instruction fetched?
The instruction for 22, so that should be the instruction that's in address 22.
So that's 11. Okay.
Which I think is that here is extended.
No, this one is clear. Okay. So here's our instruction 0011, and it's a clear. Okay. And so now if we single step, we should go to 23. Okay. To 23, and we see that the instruction there is 0001. If we go back here and look at the program listing, in fact it is 0001, and that's something to do with the extended operations buffer of the tape drive. We're not exactly sure. But the next instruction is 0024, and that is gonna, that should be...
So that's gonna jump. So
right.
6752 is gonna jump us to the DAT-set label inside of this program listing.
So we have 6752. If we look here, 6752 is going to be a jump to the DAT-set label that's been set in the program. And is there a jump? 6000s are jumps?
Typically, yes. And then, I mean, in the next listing, there's also the 7000 jump. So it's, I think, whatever. I think it starts with the 6, and then once you add the number to it for the address at the location that you're jumping to, it could overflow to 7.
Oh, okay.
Maybe.
I'm not sure either. So if we execute this jump, it's going to take us to address 752 in this instruction field, which is going to be here. So have we jumped yet?
Nope, not yet.
Okay, so we're still at instruction 24.
And it's still thinking we're going to go to 25.
Yep. Aha.
So now we actually went to the 0 address, where we're storing our return address from the jump.
So when you make a jump, it stores the return address into the 0 address. And that's just part of what the instruction does, and this is why jumps take longer.
5 microseconds or something. So now we're at 752.
Okay.
After we've stored that address and made our jump.
Right. Okay, so now we're at 752, and in the at that address it looks like we have 0047. So if we go here and look at 0047, that's what's set. It's set the value into 7, or it's going to set, rather, the value into 7 that's here in 0. So address 0 is what we saved as a return address. We're going to store it into address 7, because if we make another jump, we don't want to lose that return value. So if we do this here and single step this,
753.
Okay. What does 753
so
do?
It's the next address is used by that set instruction for part of the addressing.
Right.
So now we're telling it to go back to the 0 address, so we can store our return address into a register, so that we can make another jump from our subroutine to another subroutine, and then use that second subroutine's return address in the 0 page, the 0 address.
Right. So sets and jumps can either be immediate, where it jumps to the next, to the value in the next address, or they can be sort of indirect, where they jump to the value. Wait, I'm getting this confused. I'm getting that confused, aren't I?
So the jump, when you make a jump, it stores the return address in the 0 address.
Yeah.
And then when you do a set instruction, the set is use set to transfer, basically to set a value in a register. And the first 20 addresses after the 0 address are reserved for registers. And so if I hit continue again, it's taking the address that was in the 0 from our first jump, putting it into address 7, so that we still have that return address.
Right.
And then if I hit again, so now we're back at 753, 754.
Okay.
And then that's where it's going to do the checking.
754 is going to see if SNS4, the sense switch 4, is set. And if it is set, then we're going to jump to fixstat, which is a thing that where basically this chunk of code is making a block of data to use for the test. And either it can be based on fixed input, or it can be sort of a random number generator algorithm, pseudo-random, of course. And so what this is saying is if SNS4 is set, then we're going to jump to the fixstat function where we use fixed data. If it's not set, this kind of checks it again. If it's not set, then we're going to jump to the random data, and we're going to generate our data randomly. I remember it wasn't the jumps, it's set that can be immediate or not. And that's what I was confused about. And so we see set 7 here. What that's saying is set the data that's in 0 into register 7. But you can also have a set where set immediate, where it's whatever is stored, whatever's in the next address, that's what you set. So there's kind of two modes for how set works. So that's kind of showing you how we're stuck in this program and how we can single step through the program. What we're going to do now is try to figure out where the program is getting stuck, and then we'll go from there. We'll come back when we have something else to show you. So that's all for now.